So dear students, today I'm going to discuss about a new chapter, that is laws of motion. And a laws of motion means, we'll discuss about basically Newton's laws of motions. And this is a very important chapters in mechanics. You can say this is the backbone of mechanics, because everything that we will discuss later on in mechanics, that will depend on this laws of motions, that is basically Newton's laws of motion. And this is basically an introduction class that I am going to give you some introduction of laws of motion. And in this introduction class, first I like to give you some realistic examples. Okay, so by using these examples, you can understand that how these laws of motions are involved around us. Okay, so first I like to give you an example that if you want to move a football which is at rest, then obviously you have to kick it. Okay, and you can see in this animation that if you want to move the football horizontally, then you have to give the force on the football horizontally. And obviously you can see in this picture that the football is in motion under the force. Okay, and the force is given by this boy by his foot horizontally. Okay, similarly, if you want to push an object upward in upward direction, then you have to give and push obviously in upward direction. In the same thing, I can explain you by using this example that if you want to kick the football on upward direction, then you have to push it upward along upward direction. So not in this like this. If you want to throw something in upward direction, then also you have to push upward force. Okay, so from these two examples you can understand that you have to put or you have to give the force on that object, or you have to push something. If you don't want to use the word force, basically this is the word which is used in physics basically. But if you want to tell it in this language, that you have to just push or pull in the direction along which you want to move the object. Okay, so from these two examples, it is very clear to you that if you want to move any object along a particular direction, then you have to push on this object. You have to give push on this object. Okay, but you can see that all these examples, for all these examples, what is basically, you can see that you have to connect with the object. Okay, I can give you another example also, that a bridge causes the branches of tree to swing clearly. Some external agent is needed to provide force to move a body from rest. You can see this animation also, with this animation also, that a bridge causes the branches of tree to swing clearly. So here also a force is needed, and this force is also in contact with the object. All the example, you have to contact with the object, then the object is moving. Okay, but always it is not necessary. I can give you an example where the contact is not needed actually. Okay, so an external force is needed to retard or to stop motion. Obviously, in the previous examples, that you can see that we want to move the object, so we want to give an acceleration to this object. If the object is at rest, we want to move it. But sometimes what you have to do, you have to just give an external force to retard or to stop the object. If the object is in motion, then if you want to stop the object, you have to give an external force also. Okay, so like this object is this car will be stopped. Okay, when it is facing some external agent, some external force that is want to stop this car. Okay, and the people which is the driver which is on the car, you can see its motion, but this motion we'll discuss later on by using the inertia also. But here if you just concentrate on the car, then you can see that the motion of the car is suddenly stopped when it faces a wall or barrier like this. Okay, so an external force is needed to retard or to stop the car also. Okay, not always to accelerate the car, but sometimes to retard. If you want to get the retard motion, you have to give the force also. Okay, and you can see in your realistic situations that sometimes we use a brake to stop the car. Okay, sometimes you can see, so if this is a car and if you want to retard the motion, so you have to push brake. Through brake you have to push the car. Okay, So here the process is good here, because there is no accident here. But in the previous examples you can see that if you suddenly get a barrier, then accident should be happen, obviously accident will happen. But here that's why we don't want to stop the car by using wall, something like that. Obviously we will use brake. Okay, so by using brake, you can see here in this animation, you can see that the external force is needed to retard or stop the motion. Okay, now what I want to discuss previously, that in this example the external agents of force is in contact with the objects. Okay, I can give you another example also, where you can see that if you want to move this small car, then you have to push it, and by when you want to push it, or you want to give the force on this car, you have to connect with this, you have to touch with the, you have to be touched to this object. Okay, so you have to, if you want to give the force, it will be in motion, forward direction. Okay, forward direction. But here to give this motion, you have to push the force, and this force is usually with contact, force with contact. But if I give you another example, that a magnet can attract an iron piece from a distance, but here you can see there is no need of contact. Okay, this is an iron piece and this is a magnet, and the magnet will attract the iron piece, but there is no need of contact. So this is a very good example of force without contact. So you can see from these examples that there are two kinds of things happening, that one is the forces which need contact, and there are some forces which need not contact. Okay, so there is some you can see the contact force, and there are some non-contact forces. So two types of forces are there, obviously. One is contact force and one is non-contact force. Okay, and it is clear that the external agencies can also exert force on a body even from a distance. You can see, even from a distance, a magnet, a iron piece, always maintain a distance, but it can attract the iron piece. Okay, so now let me conclude that what is force actually. From the examples you can see that sometimes we have to push the object, sometimes we have to pull the object, sometimes we can push or pull by contact with the object, or sometimes you can push or pull the object without contact, that is from a distance. But each and every time what you want to do, you just want to do the change of the state of the object, the change of the motion, the change of the state of motion of the object. So if the object is in motion, then you can give the object more accelerations, or sometimes you want to stop the motion, or if you give push or pull to the object, then what will happen, the object will be, sometimes it will be moving, sometimes it will be stopped. Okay, and sometimes maybe there is no motions, but the shape of the object can also be changed. Okay, so you can arrange all these words in a form, of very compact form, and that you can tell that this is the definition of force. So you can write as a definition of force that force is a pull or a push which generates or tends to generate motion in a body at rest. So the object which is at rest, then by using push or pull, what you can do, you can generate or tends to generate motion in a body. Or what you can do, you can stop or tend to stop a body in motion. So the body which is at rest, by using push or pull, you can generate or tend to generate motion, and the object which is in motion, by using push or pull, what you can do, you can stop or tend to stop the body, or sometimes what you can do, the change of the shape of the body. Sometimes the push or pull make a change the shape of the body. So what is force? Force is a push or pull which generates or tends to generate motion in a body at rest, stops or tends to stop a body in motion, or tends to change the shape of the body. But the last part, that is tends to change the shape of the body, we will not discuss here, because in a separate chapter like in elasticity we will discuss this thing in great detail. But here obviously we are concentrating on the motion, that is maybe it's accelerated motion, maybe it's a retarded motion, but we will discuss basically here the force under motion. Okay, so you can see if you want to move this object maybe there is a push, or if you want to move this object by using this string, it is a pull. Okay, so it may be push, maybe pull, or sometimes you can see the shape will be changed. Okay, sometimes you can see in these kinds of accidents, the shape of the objects will be changed. So all the examples, the effect of force, these are actually the effect of force, obviously. Okay, and here you can see in this example, you can see that here the car is stopped suddenly by force, and here also the cars are stopped suddenly, but the shape of the cars are also changed during accidents. Okay, now let me discuss about the internal forces. So what we have discussed till now, all are the external forces, because only the external forces can cause motion, but the internal force does not cause motion, because the internal force is always acting from inside the system. Okay, so let me define the internal force. So what is the internal force? If the force applying agent is inside a system, then it is known as internal force. It does not provide motion to the system, obviously. Okay, and for example, if you are sitting in a car and you push it, it does not move, obviously. But if you come out of the car and apply the same force, then it moves, maybe. Okay, so you can see from this example, if you inside the car and if you want to push it, it does not move. But if you come out of the car and apply the same force, then it may be moved. Okay, so internal push does not move the car, but external push can move the car. Okay, so now let me discuss some MCQs on these small topics. So obviously the MCQs will be very simple at your level, obviously. So what is force? What is force? Option A, it is a pull or a push which tends to move a body, obviously. Stops or tend to stop a body in motion, obviously. Tends to change the shape of the body, it is also correct. All of the above. So option D will be correct, obviously. And I can remind you the force. What is force? And you can see all the options which are given here in A, B and C are in the definition. Okay, so this is how we can conclude that option D is correct, that is all of the above. Okay, and if I want to ask you that what is an internal force, then obviously the answer is very obvious. Force applying agent is outside the system. No, obviously not. This is an external force. Force applying agent is inside the system. Yes, obviously. It provides motion. No. Both A and C. No. So B will be the correct answer. B will be the correct answer. And if you see the definition of internal force, then you can see that if the force applying agent is inside the system, is known as internal force. It does not provide motion. So obviously B is the correct answer. Okay. Thank you.